Hello and welcome to Scholar Fedu. This is our UTME prep series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we are looking at the UTME questions for chemistry for the year 2015. This is the second and the concluding part of the recording. We are going to be looking at the last 20 questions. Before we continue, please don't forget to subscribe to our YouTube channel, like and share our content. You can also visit our website at scholar.com to practice the UTME exam for free. We have another question related to acid, base and salts. What volume of 0.1 mole per dmq solution of sulfuric acid will be needed to dissolve 2.86 grams of sodium carbonate decahydrate crystals? We have the atomic masses of hydrogen, carbon, oxygen, sulfur and sodium given here. First, we start writing the equation of reaction between the sulfuric acid and the sodium triazocarbonate. Now, generally, when an acid reacts with a triazocarbonate, okay, a salt, carbon dioxide, and water is produced, and that's what we have here. Now, we notice from this reaction that 1 mole of this sulfuric acid reacted with 1 mole of the sodium carbonate. Next, we are going to calculate the molar mass of the sulfuric acid, which will be the sum of the atomic masses of the elements in it. So we have the atomic mass of hydrogen as 1, multiply that by 2, plus atomic mass of sulfur 32, plus the atomic mass of oxygen multiplied by 4. So we have 4 times 16. By the time we evaluate this, we are going to be having 2 plus 32 plus 64 equal to 98 grams. Next, we are going to find the molar mass of sodium triazocarbonate, okay, heptahydrate. That will be the molar mass of this sodium carbonate. Okay, so we have 2 times the atomic mass of sodium, which is 23. We have these values from here, 23, plus the carbon there is 12, plus 3 times the atomic mass of the oxygen, which is 16, plus we then look for the mass of this hydrate as well. So this is going to be 7 times whatever is the mass of this H2O here. So in H2O we have 2 of hydrogen plus 1 of oxygen. So we have for that 2 times 1, that's 2 times the atomic mass of hydrogen, plus the atomic mass of oxygen, which is 16. Alright, 2 times 1 is 2, plus 16 is 18. So that's why we have this 18 here. If we evaluate everything that we have here, we'll be having 232 grams, which means that 98 grams of this sulfuric acid reacted with 106. It reacted with 232 grams of sodium triazocarbonate. Okay. Then we now say X gram of this sulfuric acid will react with 2.86 gram of the sodium triazocarbonate. We then set up a ratio here. Alright, we set up a ratio here. So we have 98. Okay, 98 over X is equal to 232 over 2.8. Alright, this will be 232 over 2.8. Then from here we can cross multiply this here. Use this denominator to multiply the numerator here, this to multiply the numerator here. So we have 98 times 2.86 is equal to X times 232, which is 232X. So this times this will give us 280.28. To get our X here, we divide both sides by 232. When we divide both sides by 232, we'll be getting X to be 1.2081 gram. So the number of moles of the, so this is the mass of the hydrogen, the hydrogen triazocarbonate, the tetraosulfate acid, tetraosulfate acid here. Now to get the number of moles of the tetraosulfate acid, that will be equal to the reacted mole, okay, the number of moles that reacted here, over the molar mass of this tetraosulfate acid, which we calculated there as 98. So we have this divided by 98, and that will be 0.01 approximately. Okay, but what we are required to find in the question is the volume. We then recall that the number of mole N is equal to the concentration times the volume. Okay, the concentration times the volume. Alright, and we have the concentration. This is concentration, and that is given as 0.1. That is 0.1 mole per dm cube solution of tetraosulfate. That's the concentration of the acid. So you say V is equal to, from here to get our V, we are going to divide both sides by N. So V will be equal to N over C. So the number of mole is 0.01 divided by the concentration, which is 0.1. 0.01 divided by 0.1 is going to give us 0.1 dm cube. When you look at the answers that we have here, they are in centimeter cube. Okay, which means you have to convert from this dm cube to centimeter cube. To do that, 1 dm cube is 1000 centimeter cube. So that means you have to multiply this by 1000 centimeter cube. 0.1 times 1000 centimeter cube, that will give 100 centimeter cube. That is the volume of the acid that is used in this reaction. Alright, the solution with the lowest pH value is, so yeah, this question is not about quantity. Okay, so let's not be fast to jump to this and say 20 milliliter, because I mean there is more of this. Okay, it is about the concentration. Okay, what you need to look at is the concentration of this substance in question. Okay, now if you look at we are going to look at the pH value. Okay, the pH value, and for the pH value we need the concentration. The pH of an acid is minus log of the concentration of the hydrogen in that acid. Alright, now in this first one here, the concentration here is 1 over 10, that will be 0.1. If we take minus log of is 0.1 base 10, this is 0.1, then we can write it as 10 raised to power minus 1. 10 raised to power minus 1 means 1 over 10 raised to power 1. Okay, now 10 raised to power minus 1, then we can bring this minus 1 to the back. Okay, I can using some of the theories of logarithm from mathematics. We can bring this minus 1 to the back. Now we already have a minus here, so write this as minus 1, then we bring this minus 1 again, you are going to have minus 1, then log 10 base 10. Okay, minus times minus will give you plus. 1 times 1 is 1, log 10 is 1. Alright, so you are going to have 1 times 1, and this will just be 1. Okay, so the pH value of this one here is going to be 1. This substance here is going to be 1. For the next one, okay, so it will be the same thing for this one too. 10, like 1 that will be there, because they have the same concentration, 1 over 10. For this one, 1 over 5. Okay, so our 1 over 5 is equal to 0.5 in decimal. If we take the log of 0.2, you'll be getting is 0.699. Okay, you get 0.699. So for this one, the pH is 0.699. Don't mind this approximation. Alright, don't mind this approximation. Is this 0.699? The next one, if it is 1 over 8, okay, 1 over 8 is 0.125. If you take log of 0.125, you get 0.903. If we now compare the pH values of this acid here, for these two here we have 1, for this one here we have 0.699, for this one we have 0.903. The one that has the lowest pH value here is this. Okay, so the solution with the lowest pH value is 15 milliliter of this of the hydrochloric acid here. Next, in which order are the following salts sensitive to light? So the options there we have from like the highest to the lowest. Okay, now silver chloride, that is AgCl, silver bromide and silver iodide, they are silver halides that are used in photography. The most sensitive of them to light, okay, the most sensitive to light is the silver iodide. The silver iodide is the most sensitive to light. The least sensitive is silver chloride. Okay, is silver chloride. So you have silver iodide, okay, is more sensitive than silver chloride, which is more sensitive than more sensitive than silver bromide, which is more sensitive than silver chloride. A metal M displaces zinc from zinc chloride solution. This shows that, okay, for a metal to displace another metal, like zinc for example here is a metal, for a metal to displace another metal from its solution, then that metal must be more electropositive than the metal that it is displacing. Okay, so that this metal M displaces zinc from zinc chloride solution shows that this metal M is more electropositive than zinc. Steam, okay, that's water, changes the color of anhydrous cobalt 2 chloride form. Now this is one of the tests for the presence of water. Okay, adding it to cobalt 2 chloride, it will change the color of cobalt 2 chloride from blue to pink. Okay, from blue to pink. But with so you could use cobalt 2 chloride to test for the presence of water. In that case, the water will change the color of this cobalt 2 chloride from blue to pink. or you could use copper sulfate, in which case it will change from white to blue. Okay. When at equilibrium, which of the reactions below will shift to the right if the pressure is increased and the temperature is kept constant? So pressure affects the equilibrium position of a reaction involving gaseous species. Okay, and an increase in pressure, is going to favor the side that has the lesser number of moles of that gaseous species, Now if you look at this here, okay, the number of mole of what we have here, the reactant here, is 2. The sum of the number of moles of the product here is 2 plus 1, that is 3. Okay, here we have 2, here we also have 3. Okay, just like these two here. Alright, here we have 3 on this side and we have 2 on this side. Here we have 2 here and 2 here. In this case there will be no effect here, there will be no change here, because they have equal number of moles of gaseous species on both sides. There are 2, and here you have 2, like 1 plus 1 here, so it is 2. So this one there will be no change. Okay, so now these two already, it's very easy to answer this question, in that you can easily, because these two here they have the same condition. Okay, we have 2, the number of moles of the gaseous species on this side is 2 and on this side is 3, so it has to be this one. Okay, but let's look at the question very well. The question is, will change to the right if the pressure is increased. So I said that an increase in pressure will favor the side that has the lesser number of mole. And if you look at this one, the number of mole of the reactant here is 3, that is 2 plus the 1 of this diatomic oxygen here. So we have 3 here and 2 here. If we increase the pressure, this side has the lesser number of mole here. Okay, so it will favor this side here. Next question: mineral acids are usually added to commercial hydrogen peroxide that is to minimize its decomposition. Okay, to minimize its decomposition. Which of these properties gives a solid its definite shape? That is, the strong intermolecular attraction between the particles of the solid is what gives it its shape. We have our website at scholar.com, where you could practice exams for free, the UTME exam and the post-UTME exam. It also features modular quizzes in physics, chemistry and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at scholar.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. When a crystal was added to a clear solution of its salt, the crystal did not dissolve and the solution remained unchanged. This shows that the solution was that solution was saturated. Okay, it shows that it was saturated. That was why the new crystals that were added to a solution of its salt did not dissolve, because already that solution, okay, has enough solid. Okay, it has taken enough solid, it has enough solid that it can dissolve at that temperature. Okay, so a saturated solution is a solution that contains sufficient amount of solute that it can hold or dissolve at a particular temperature. So if you add more solutes to it, those ones that are adding to it, they will remain undissolved in it unless the temperature changes. Okay, that's when some of them may dissolve. Okay, or some of them may even crystallize out. I think some of those that are dissolved before, they may even crystallize out. Okay, so the solution there is saturated. This is why the new solutes that are added to it, the new crystals of a solution of that sort that is added to it, did not dissolve. The substance that is used in the steel industry for the removal of carbon, sulfur and phosphorus impurities from pig iron is, that is oxygen. Okay, oxygen is added in the steel industry to remove the carbon dioxide, sulfur and phosphorus impurity. So what oxygen does is it oxidizes the substance, okay, into gases. Hydrogen sulfide gas can act as a precipitating agent for metals, and it can act as a reducing agent as well. Okay, it can act as a precipitating agent and as a reducing agent. Which of the following is used as a rocket fuel? That is triazonitrate. Okay, triazonitrate is used as a rocket fuel with oxygen, with liquid oxygen. The bleaching action of chlorine is effective due to the presence of it is due to the presence of water. Okay, due to the presence of water. So the chlorine dissolves in the water to form hydrochloric acid and hypochlorous acid. All right, this hypochlorous acid is what generates, what decomposes to generate nascent oxygen, which bleaches the material. Okay, but if you look at this, you see that the starting point here is that chlorine reacting with the water. If we didn't have this, then we would not be having this hypochlorous acid, which will eventually generate this nascent oxygen. Okay, that is reactive monoatomic oxygen that bleaches the material. So it is the water here that kind of like boosted or facilitated the bleaching action of the chlorine. Mineral acids are usually added to commercial hydrogen peroxide. So that is to minimize its decomposition, to prevent it from decomposing. So those mineral acids act as an inhibitor, to prevent the hydrogen peroxide from decomposing.